Welcome back, everybody. Our next speaker is Taylor Scott from Sendoso, and he's going to be speaking about application logging. Taylor, take it away.
Thanks, Sean. Like Sean said, my name is Taylor Scott. I will be speaking about the 5 W's of application logging. A little bit about myself is I am a software developer at a company called Sendoso. I used to work most recently at Deseret Book, and that's probably where people used to know me most from. I'm the author of a couple gems. Solidus JWT is one of those, Solidus identifiers, and then one that we'll probably be talking about later in this talk is JSON tagged logging. A little bit more about me. I've got 4 animals where I live right now. Also, I'm actually traveling right now, so I'm presenting from an Airbnb on the couch. That's why I look so comfortable. So apologies. I'm also a bad public speaker, so forgive me if I make any mistakes. But these are my 4 animals that I live with normally. It's my cat, Freddy. He loves to chase lizards and toads. And then we have Spunky. She's about a little over 15 years old, but she's still bringing back rabbits and gophers, some animals that are bigger than her, actually. She's a pretty fierce hunter. And then we've got Mango, who's the angel of the family, very smart dog. She loves to herd us, make sure we're all in the same room. And then we have Jazz with the pig snout. She's probably the least favorite animal just because her intelligence isn't that high, but she's still a little cuddle bug. I also tried to grow a beard once. This is me with the ocean spray in my beard. And an equally good idea / bad idea was I gave myself a quarantine haircut. This actually made my wife pretty angry when I did this. So she immediately scheduled someone to come over and cut my hair. What made her even more angry, though, was I photoshopped her out of that first photo, and she made me add this slide just to include her. So here's a little shout out to her. So I got to give my current company a little bit of a shout out since they're allowing me to be here today. They're called Sendoso. What they do is they are kind of a CRM for sending gifts. You can send digital gifts or you can send physical gifts. And what they'll do is they'll package everything up in your company colors, company logo, and make everything nice and presentable. You can also send just about any gift card you want by email, where people can claim. So it's a really cool company, really fun to work with. I also got to give a shout out to Deseret Book. I wouldn't be here had it not been for Deseret Book. Deseret Book's how I got into the Solidus community and was able to learn a lot of great things. So now that I've wasted everyone's time, and cut some time off the clock for myself as well, let's get back into the 5 W's of application logging. If any of you went to school in the United States, the 5 W's are going to be fairly familiar. They are something that growing up in grade school, they teach us at a young age whenever we write a paper or a report. And these 5 W's are who, what, when, where, and why. And just as it's important when we're writing a paper, this is also something that should be important when we're writing our logs. Oftentimes we look at our logs and we think just a plain message is going to be sufficient. But when you look back through your logs on your log manager or wherever, sometimes you find that not to be the case. So let's talk about the who for a little bit. When we write a log, we need to ask ourselves, who does this log pertain to? And will I be able to look back at this log and identify who it pertains to? For me, the who is going to be something like a user ID. It could be a cookie. It could be the process or the machine or an IP address. Having all of these is great, but obviously not always practical. But I think having at least one of these is going to be important to remember, to include in every log. So you know, okay, this is where this happened, or this is who it happened to. And that's why I include the machine ID as well, because the machine could be a who. Let's talk about the what. The what is pretty much the message. what is this log about? And that's our message. We can do better sometimes. Oftentimes, I've seen we write something like, this record failed to save, or something like that, or gateway timed out, but we don't know what payment ID was that. So sometimes having a model or a table row ID on that entity, or just logging the plain exception is a good idea as well. But having IDs associated with that message is going to be very handy when you look back through your logs, because sometimes you notice, oh, I've got a message, but I have no idea what that applied to. And so it can be a little bit more difficult. I also have the spree events on here. I think an important thing to know about logging is it's not just about error reporting. Logging is much more than that. There's a lot of analytics that can be gained from logging. And the spree event is a perfect injection point for gaining some analytics of what's happening in our system. So this is another thing where I think at least one of these is going to be important that we include in all of our messages. The when is going to be very easy. This is a timestamp. Every log should have this. You got to be careful with the active support simple formatter, I believe it is. It does not include timestamps by default. So just make sure most formatters are going to have a timestamp, but ensure all of your logs have a timestamp if it does not include it, because very important, obviously. And the where. So you'll notice that some of these overlap with the what. The what and the where can be very similar if you think about it deeply, but a stack trace. So if you have the stack trace in your logs, it's very easy. Okay, well, this is where that error occurred. And you can trace back all the files that it happened in. It makes it very easy to go to that file and look at the error, see what happened. A request ID. So sometimes it's nice to know, oh, this, maybe you're looking at an error. And if you have a request ID, you can look at all the other logs on that request to see kind of what else happened during that request. A machine ID, a process ID, and of course, if you use Sidekick or ActiveJob, having a job ID or a worker ID, as well as maybe the queue name, can be very helpful when we're trying to go through our logs and figure out stuff or analyze what's happening on our system. And now we have the why. This one's kind of a little bit harder to tie in. But when I say why, when you write your logs, ask yourself, if I look at this log by itself, am I going to know why this thing happened? And oftentimes, you're going to find that it doesn't. And so the why is important here, because you need to ask yourself, can I aggregate this log? Can I search? Can I filter? And will I be able to analyze? Because oftentimes we want our logs to tell a story. I use the example of having a request ID. That's an example of being able to ask why. So if an error occurs, we can look back through the entire request on all the other logs, because we can filter by that request ID. And we'll be able to see, okay, this stuff happened just before this error. So let's take a look at that, and we can have better insight. I also want to talk about consistency. This is important when we ask why something happened. Consistency is very important in log managers, especially if you have multiple apps, multiple APIs. Sometimes you have different formatters, sometimes different languages, Ruby, Node. It's important that wherever these logs end up, you need to make sure you're consistent. Even if it's just one application, you need to make sure your logs are formatted in a consistent way and it's able to stay clean. The reason this is important is for analytics mainly, but also for reliability. Here's an example of where consistency can cause unexpected behaviors when you're analyzing logs. I have 3 lines here. They're all kind of the same message, but they have a different tag on them. I have an order with an order number, and then I have order with an order ID. And then I have order, which doesn't pertain to an actual e-commerce order, but rather than the sorting of something. So this is an example of where things are not consistent. Now we can kind of work around order ID and order number. It could be a little bit annoying, but we can account for that. However, how do we know which order number and which order ID are the same, which can cause problems? But when we get to the order where it means something different, that's where problems are caused. We might skew our analytics a bit if we're not consistent on our naming and our formatting. Also, to keep everyone awake, if you want to just write conformity is cool in chat, just spam it away because that's something very important. Your logs should conform to a certain schema. So I want to talk about some of the log managers out there currently. Some of the ones I've used are Rollbar as well as Elasticsearch or Beats. All of these are very great solutions. And hopefully what I talk about today will integrate perfectly with whatever you're using. Hopefully it's valuable to whichever solution. But I do want to talk about the Ruby logger specifically in order to kind of understand our logs and how to get the most out of our logging. We need to understand the Ruby logger. This is just a quick example of all the methods it provides. Ruby logger has certain severities. We've got debug, info warn, error, fatal, and unknown. Unknown is probably the least used, but good to know that it's there. And each of these severities will coincide with an integer 0 through, I think, 5 it is. 1, 2, 0, 1, 2, 3, 4, 5. Yeah. 0 being debug, 5 being unknown. Just something to keep in mind. When we instantiate our logger, there's several ways. So this is taken directly from the Ruby logger repository on GitHub. Pretty much what you can do is you can pass in the standard error stream, the standard out stream, or you can pass in the path to a log file and it will automatically create that file if it doesn't exist, or it will start appending to it. You can also pass in a file handle to the logger, and that will do the same thing as long as you give it the right permissions. If you didn't want it to create, if it didn't exist, you could remove that file, create permission. Some lesser known ways to instantiate the logger is you can actually rotate your logs automatically. This is very nice, especially for production environments. So the first example, you'll see a 10. What that says is keep 10 logs. And at about 1 megabyte, I think that's 1 megabyte. What we're going to do is we're going to say, okay, roll over to the next file. So log 0 will reach 1 megabyte, and then it will create log 1. And it will do that until you have 10 logs, and then it starts all over. So this is nice so that what you'll notice sometimes in production, if you're not rotating your logs, your container or your host will eventually grow in memory and then sometimes just crash and restart. It's very hard to tell what happened because it doesn't happen often, but it will happen and it can happen. Some other ways that you can rotate the logs is you can actually pass in the string daily, weekly, or monthly, and that rotates your logs in that time frame. So how do we add messages to the logger? So we went over this in a previous slide before. We have those info debug methods. What's important to know is all of those methods call this add method right here. This is probably the most important method of the logger as it kind of bootstraps everything together. So this is a perfect injection point right here if you wanted to do custom behavior. This is where you'd probably want to do it because every other method calls this method in order to add a log. There are 3 parameters. It takes in a severity, a message, and a prog name. If you want to call it, this is what it would look like. So you can see instead of calling logger.info, what I'm doing is calling logger.add. And I pass in the info severity, my message, hello world. And I'm just giving a prog name of my app. Usually prog name is nil. However, it can be a good idea to set that if you have multiple applications. And you can see this nice outputted message. We have this I for info, and then we have our timestamp. And if you see that hashtag 80886, that's going to be our process ID. And then we have our prog name and our message at the end. So it's a nice string right there. This is what, if you look at the actual code, this is what the info and warn methods actually look like. And as you can see, it's just delegating to that add method. Something interesting to point out here is you'll see that info doesn't take a message. This was actually confusing to me at first. But what happens is when add is called, you can see we even pass in a message of nil. It does some kind of parameter resolution, and it's a little bit weird in my mind, but what happens is it kind of searches for that message through both the message and the prog name, as well as the block that's passed in. So that message gets resolved within the add method. So don't let that confuse you too much. So let's talk about the format of our logs. Sometimes maybe we don't like that default format, or we want to format our logs in a way that's more consistent with the rest of our logs, or whatever our reason, we can do this. So we've got, there's a logger formatter class that we can inherit from. And this method, or this class, has a method called call. And like the add method in a way, well, no, it's not like the add method. This method takes in a severity, a timestamp, a prog name, and a message. And all you have to do is return a string from this method. So this method takes care of serializing our logs. So whenever we're outputting our logs to the console or to a file, this is where they get formatted and serialized into that nice, pretty string. Here's an example. This is just a quick example of, say, if I wanted to serialize my logs as JSON strings. So what I've done is just created a hash where I pass in those keys and values, and then I call to JSON on it. What you'll notice here is I've passed in a new line. Don't forget to add a new line at the end of your string. Otherwise, what you'll find is all of your logs are going to end up on a single line, which could be very bad for your log manager or just whatever you're parsing. So always include that new line. I even have a slide just for that. Include the new line in your formatter. So kind of went down a rabbit hole here talking about the Ruby logger. So let's kind of get back to the 5 W's of application logging, and let's look at some examples. So some of these are going to be from the Solidus repo. And the question I want everyone to kind of ask is, how can we do better? What can make this log message a bit easier to parse or to read, or to even identify the root of the problem? So here's a method on the API-based controller. It's for an invalid resource. We're doing a great thing where when something's invalid, we're logging an error. And we say invalid resource equals, and we output all the error messages. Now, one of the things that I personally think, and obviously this is my opinion, and it could be different for everyone else, and I'm not saying this has to be done. But one of the things that could be helpful here is we're outputting all these error messages to our logs, which is great. However, we don't know what resource that pertains to. We don't know the resource class. We don't know the resource ID. We might be able to kind of put it together if we, by what kind of message is being outputted. But it might be a little bit more beneficial or easier to just also add the resource ID and resource class to this message. That way, when we see it in our log manager or in the file, we can immediately say, okay, this is the resource it happened on. And it might be something that's, it might be just a single resource that's having issues, maybe inconsistent or dirty data in our database already. Another thing is maybe it doesn't need to be an error. Maybe it's just a warn, because we're obviously handling this gracefully. So it might be a good candidate for just to use a warning message. But that's also an opinion. Doesn't have to be everyone else's. Here's another example, very similar to the last one, but you can see we're actually we're outputting the exception itself. So this is great. However, what we're doing is, as we looked at our formatter before, that call takes a message, and we are eliminating the benefits of letting that call method format this exception for us, and we're just passing it a string. So, for instance, when we have when we pass this in, it's a plain string. The formatter just reads it as a string, can't do anything else with it. However, if we pass in the exception itself, the formatter has the option to be like, oh, this is an exception object. Let me do a little bit more. Let's add the error class. Let's add the error name. And let's put the stack trace here. And we can format it a little bit differently from the rest of our logs. Another thing, just like the last one, is we don't know which stock item had insufficient stock, or which order maybe it occurred on. So these are also kind of important things to keep in mind. This isn't from anywhere in the Solidus code, but this is something I wanted to bring up. Is I've seen, and I've done this oftentimes, and that's when we rescue an error, and we what we do is we send it to the flash error object, and then we send that message to the client. So one of the problems with this is our client is receiving all these error messages, but we have no way of knowing that because we don't have any logs of it. So we might have a customer call in and be like, hey, I'm getting a bunch of errors here, and there's no way for us to be like, oh, I can't find that error message anywhere. So a good rule of thumb is if we're rescuing an error and we're not re-raising, we should be logging an error, whether it's a debug, a warn, an info, whatever the level, we should at least be logging this error right here. Okay, so we've talked a lot about the who, what, when, where, why, and all these things to keep in kind of context, but how do we maintain that context? If we look at something like this, this isn't practical. We can't rely on other developers to always include context in their logs. We might not even have access to all these variables. So, I mean, it creates, it violates the dry principle, essentially. So we don't want something like this. This is not a good way of doing it. So in comes active support tag logging. This is a great tool. I live by this. Anytime I'm setting up logging in a system, this is what I'm using. And what you pretty much do is you instantiate your logger as you normally would, and then you pass it into active support tag logging.new. And what this does is it extends our logger to have a method called tagged. And this tagged takes in one or more tags. And there's an example of how I use it here. And then you drop into a block. And anything within that block is going to inherit that tag. So as you can see, I call logger.info processing order and completed order as an example. And if you look at the output, you'll notice that these tags are automatically on there. So now when we call tag, we no longer have to rely on other developers to include this context. It's automatically there. So we just need to find a good injection point, and then we have those valuable tags in our logs all the time. We don't have to rely on anyone else to maintain that. And it's a great way to maintain that context. So let's talk about some good injection points. Rack middleware. This is a great place for tag logging. This is a basic rack app right here that I've used in production and I still use. Essentially what it's doing is I call rails.logger.tagged and I add a request ID tag. And then inside the block, I delegate to the rest of the application. So this is where it goes to our application controller and so on. So basic rack app, I do this for request ID. If we're using device or warden, I'll also create one for user ID, which is also a great way of doing things. But I'll go into that a little bit more later. If you're using the Spree API base controller, you'll notice that if we want a user ID, because we don't authenticate on the rack, we can't use middleware. So around action on a base controller is a good spot to add tagged logging. So this is how I add a user ID to all of the logs through the API. Because we don't have a user on the rack yet, it gets authenticated on the base controller. So once we've authenticated, we can use this around action. So the user ID is set, and then we just add that tag and then delegate to the rest of the API code. And that way we now have a context of a user throughout our entire app on all of our logs. Here's another one. If we use Sidekick, or if anyone uses Sidekick, there's probably a similar way to do this with ActiveJob. But Sidekick also has middleware. What Sidekick doesn't have is request IDs. There is no request IDs for background workers because it doesn't work off of HTTP requests. They're pretty much just processes or workers running in another thread. So Sidekick does have middleware. So something that might be important to our logs are the Sidekick job ID and the queue name. This helps us to identify logs which are affiliated with a specific job or even a specific queue. This can make debugging so much easier, as well as having various analytics around this is very good too, because we can see which queues are the busiest. We could look at how long jobs are running, all sorts of valuable information in that. And last but not least, but the spree event decorator. As I said before, logs are more than just error reporting. We can get good analytics from this, and this is one thing I've done to be able to do that with spree events and have logs for every spree event when it occurs. You'll notice that I have a context in here. This is something I've kind of followed for consistency. We talked about conformity rules. So this is to stay consistent. It would be dangerous for me to pass in the entire options object, as I might get, like in the example before, an order ID versus order in a sort order. You might have keys that conflict with each other that are different types or mean different things. So I've made it a habit to, whenever I call an event and pass in an object, it's going to be on that context key. And this way, when I log it, I can get the context ID and the context class name. So if it's a spree user, I know it's a spree user and this is the ID for it. And then I just have a generic message for event triggered with the event name and all that information. You'll notice something different about this. I'm passing in a hash here. This is because I usually use something called JSON tag logging. So if you prefer JSON, there is a gem that I wrote. It's last I saw when I left Desert Book, we were using this in production. And this was a game changer for us. Obviously, a JSON structure is much easier to parse. You don't have to grok it like you would a string or run regex. And it fits in with a lot of log managers. So pretty much what this does is it changes our tags. Instead of passing in a string for our tags that can be delimited by whatever, which is another thing that could hurt consistency, because you can't rely on all developers to delimit your tags the same way. You now pass in a hash. So you can see I passed in request ID as a key, and then the value, which is the actual request ID. And now the logs are outputted as a JSON string. Here's some more advanced usage of it. You can see I can pass in a whole object if I wanted to, and it outputs it. You'll notice on that first one, the message is null. So if we still wanted to have the message, I can also add the message key. And then when you log an actual error object, you'll see that it creates an error key with the error name, message, and the trace. And so it formats your logs into a nice JSON formatted string. And you can have complex data within this string too that can be searchable on the go. So this is something that is really nice to have. So why should we put on all this work to make sure our logging is good? A lot of reasons: analytics, easy debugging, easy tracing. We're lazy. I don't like spending all day trying to identify something that happened. And logging is something that makes that easier. Auditing and proof. This is also a great one. I've worked with third-party APIs, and they don't always aren't always correct. Sometimes bugs do happen, and oftentimes there's a back and forth of, hey, I made a request, but you gave me the wrong response. And there's going to be back and forth of pointing fingers. So I've made it a habit for any unreliable APIs. I log the entire request and the response. That way I can send it to them and say, look, this is what happened. And it eliminates that whole back and forth to where they're just like, oh yeah, we'll go in and fix that. Proactive versus reactive. Having logs is a great way to be proactive. What we've done in the past is we've created machine learning jobs, which will look at bad sign-ins by IP address, or even failed credit card authorizations by user or IP address. And these will trigger an alert if it ever happens, if something's out of the ordinary. So setting up machine learning jobs, or even just things like that, to be able to be proactive rather than looking back and say, oh, we had someone attack our security. It's, hey, someone's currently attacking our security, and we can do something about that on the fly. Here's just some examples. I'm actually going to exit out of this presentation right now and share a tab. So just give me 1 second, because we are going to do some live code, guys. Okay. Let me know if you guys can see this correctly. I need to pull up my tabs. Okay. So let's go with this. And we're going to look right here. So what I did was I created a just a basic Solidus app, and I applied some of these principles, started up my local web server, and just started recording some of the stuff I did. So if we look at this, let's see, so this is the latest request. Let's go down. Let's start looking at requests as they happened in order. Oh, sorry, no, I had that right the first time. Okay. So this was the first step. This is just one user, so I don't have a filter by user ID. But we can look through these logs and we can see everything that I've done. You also notice I have this message called entity change. That's because I have a paperclip style log method, but much easier to search as well. And if you look at the data, I actually log every database change. And this takes a lot of load off the database as well. So you can see we've created an order here. You could also see the path where the log was. You can see my user ID. You'll notice it's just the guest token right now. And you also notice it's an array. This is super important. And maybe request ID is also something that could be array as well. But the reason I create user ID as an array is because users have multiple contexts. So when I come to Solidus, I have a guest token. And then when I log in, I have a user ID. And it's important to keep those two together so I can trace that user steps all the way back. So I have the full story and not just half of the story. Now, you can see I have an event triggered. This is our order recalculated event. So I know that we've recalculated the order. And we also have, I should have pointed this before, this is the request ID right here. So you can see which logs apply to which request. If I wanted to filter down on that, I now am just looking at a single request. That's something that's also very nice. That's why we have the request ID. And by the way, this example is using Elasticsearch, but this can be done in other log managers as well. You can see we destroyed an entity. This was probably the order mutex. If we keep going, we can see user logged in successfully. And if we look at the next request, we'll actually now see, here we go, different request now. We can actually now see that the user ID is a 1, which is my actual user ID, and the cookie. And that allows us to be able to go back in time and look at other requests that that user may have been affiliated with. We keep going. This is just going through checkout. Oops, something just happened. It reloaded probably. And then we get an error. So you can see this error actually isn't in an error object. The reason is due to that exception not being passed into the formatter. So my formatter wasn't able to serialize that error in the way it wanted to. It was passed in as a string with some outputted messages. So this is just kind of highlights the importance of passing in the exception itself. And then make a second log if you want to add some a custom message along with it, or do it another way. Yeah, and then we have user logout. And let's just look at the event real quick. You'll see that there is a context on this for the spree event. If I'm not blind, I'll find it here in a second. Here we go. So we have the name of the event. We have the context type. It's a spree user, and we have the contact ID. So we know this specific user logged in right here. A lot of this can be done and used for analytics. Here's just some sample data. You can gather real-time analytics. It's very nice. You can even track people's locations, where's the hotspots. And then another example here, where you can track in kind of heat maps of what are the busiest times of day by country. Where am I routing people to? Just a lot of valuable data within our logs. But that does it for me, guys. I do have a finished slide, but I'm not going to go to the next one. Thank you guys for kind of bearing with me here. I hope you guys enjoyed it. And please join me in the Q&A session after this. I'd love to talk to you all and hear your questions or comments. Thank you.